Hello, my name is Ishan Said and today I'm gonna give the presentation submission for topic Grid to Vehicle Energy System for Newfoundland as a project for courses Power System Protection and Instrumentation and Control. So the flow of presentation is gonna be like we will start with the introduction, then I'm gonna discuss the primary goals of my presentation, then we will see the methodology and the work that were done and the models describing it how they work and everything. Then we are gonna discuss it and then we will jump to the conclusion. Oh, we'll jump to the results, discuss them and then the conclusion. So for the first topic, vehicle V2G. V2G is also a short form for vehicle to grid technology, which means the energy that is produced is the energy generated is enabled to push back to power grid from battery of an electric vehicle. With V2G technology, an electric battery can be discharged based on different signals such as energy production or consumption nearby. This technology provides bidirectional charging, which makes it possible to charge the EV battery and take the energy stored in car's battery and push it back to the power grid. While bidirectional charging and V2G are often used as synonymously, there is a slight difference between the two, which is not that much of an which we don't need to discuss in deep depth, but that's the basic technology which we are going to focus on in this presentation. So, for the project, there were and several goals and deadlines that were set and meet them. So, the primary focus of the project was to enhance grid stability, like use EV as distributed energy storages and use batteries more efficient ways. Secondly, we were focused on reducing the peak load demand, which which in turn says that over the time, at some point of a time in a day, there's a chance that our battery, the load there's gonna be a peak load demand where all the appliances and all the load of the house is used to the fullest, and by by use of this by analyzing the peak load, we wanted to lower the peak load demand by introducing some EVs and extra source of power, so it would reduce it and make the system more efficient. Thirdly, the objective was to promote renewable energy integration as we live in 2024 and but as we live in 2024 and we are moving to a sustainable development in energy sector. It's important to integrate the grid with an energy system which has renewable sources like EV, wind, like solar, wind, and a lot of different things. But our primary focus is solar, as solar energy has been discovered and studied in very depth till now, and it has been progressively increasing, and we know all 90% of the solar power renewable harnessing and supply chain for the solar energy, which is comparatively much more developed compared to the other power sources. So we are going to take the solar energy in our system as a renewable source of energy and work on that. The fourth most objective was to develop control algorithms. So there are several cases, like there's not an ideal case in the whole system. There isn't an ideal condition in the system like it's gonna be stable or somewhere. There at some point there are gonna be changes in the load demand, like and failures. Then energy system management between vehicles, like we shouldn't be let the vehicle batteries drain when we have to take the vehicle out. So better to it was better to harness the energy and develop algorithms using several different conditions depending on weather and other several circumstances. So the basic way to model is to model imply battery styling for EV grid. So when we see at the model, this is gonna be the basic working, like there's the grid power and also solar power. But with the grid, we are gonna power electric vehicle batteries first of the EV, and then when the battery for the EV is charged more than required, it will send the supply back to grid or to the house after the needs are surplus. And we have attached a battery to store surplus power in the system, so it would reduce the peak load demand as we discussed earlier. So, and for the modeling, we took the house located in Newfoundland. So for the modeling of the house and calculating the load demand and load estimation, we used BOP software by Instrumentation Agencies, National Instrumentation Company, where we would design the home and put the variables and all the loads, including all the loads like the heat efficiency, the heat requirement of the house, then how much is the solar penetration gonna be, then what's the layout of the house gonna be, how is it gonna be then. So when I designed it, I took the example of the home in Newfoundland where the house carpet area was 292 meters square, which is a lot, and then there was a parking area of 50 nearly of 50 meters square. And when I added the load, when I was adding the when I was about to add all the components of electricity energy consumption. So the house was supposed to be two-story. The house is two-story building with 6 bedrooms and 7 people living in it, which would have some variable loads for charging, for as like chargers and lights and everything. So that's the basic way. And when the load estimation came, it was 68.2 kilowatt hours a day at its peak. So that was an average load, so it's like 5 or 10 kilowatt hours a day was the range for that. So the electric needs of the home were met with 2.6 kilowatt of generator capacity. The operating cost of energy are currently 3659 per year. By adding 13 kilowatt of PV solar power to it and 24 kilowatt hour of battery capacity, this cost was reduced. This operating cost was reduced to $1,610 per year. The investment has a payback of 3 years, nearly 3 years, and an IR of 22.4%. This microgrid is this microgrid requires 11.11 kilowatt hours a day and has a peak of 2.2 kilowatt hours. In proposed system, the following generation sources serve the electrical load. The generic PV system has a nominal capacity of 12.9 kilowatt. The annual production is 14,206 kilowatt an year per year, kilowatt hour an year. And the Trojan battery company storage system's nominal capacity is 23.6 kilowatt hours. The annual throughput is 4.1 kilowatt hour per year. Now, for the main modeling of the home and for the whole system, it is shown in the schematic. It has been put in schematics like there would be AC power sources and DC power sources, and solar panel used is Canadian Solar CS6U 340M. The battery is Trojan SAGM 1 to 12 and inverter is 20 kilowatt. We have also used a 10 kilowatt battery genset which only serves as backup and has no dynamic impact on the system. For the electric vehicle, I prefer to use Tesla Model S as an deferrable load with 11.5 kilowatt hours of electricity load consumption, which is variable with 6.6 kilowatt hours peak, and house load demand is 58.90 kilowatt hours a day with peak of 11.80 kilowatt hours. The system takes power from grid as well as PV array. The highlighting component is the electric vehicle, which acts as both a source and a consumer of power. The excessive power generated is stored in battery. So for the solar penetration, it was important to analyze what is the solar penetration for the whole year, so we can analyze the placing of solar panels. And it was found that as a how it was found that solar radiation is 1.28 kilowatt hours per meter square per day. It ranges from that to 5.14 kilowatt per meter square per day, which averages to 3.15 kilowatt hour per meter square per day, which can be seen in figure where June where the months of April, May, June, July and August have the peak penetration of solar as it's summer, and it starts increase it starts decreasing by the it slightly starts decreasing by the end of September and October, and gradually decreases in November, December and January. The clearness index of the same site rises from zero point 0.3 to zero point 0.5. The calculated results regarding the cash flow of system is amount of the house is going to create, which is which has two cases where the first system is one with no renewable power source and grid power where over the span of 25 years the cash flow is gradually decreasing. Meanwhile, the other system with solar array and vehicle power to grid has gradually increasing the flow as coming years. From the model simulated, we were able to calculate the load consumption and optimization of the system. Optimization optimize the cost of the system. It was observed that the total running cost was $3,500 per year. It was that simple. Payback time required was 3.3 years as we discussed, and the net present value of the operation is $15,800, while the return on investment is 15.7%. The initial capital investment required was $10,000, while which provides an internal return of 22.4%, which is not bad. The several other simulation factors were this microgrid required 87 kilowatt hour per day and has a peak of 12 kilowatt. In the proposed system, the following generation source serve as electrical load. The generic PV system has nominal capacity of 36 kilowatt. Thank you. That was from my side of the presentation. Thank you guys.